Hello all, this is Radhika from Panda Key Learning. Welcome you all for engage your learning experience with Panda Key Learning anytime, anywhere, at any places. We are always supporting to the students in a technical way, and our main vision to help 10 million students easily learn the technology. So today is day 3, and the day 3 of agenda is simulation of single phase uncontrolled rectifiers. So we are going to discuss about the rectifiers. So what is mean by rectifiers? As we already know, the rectifier circuit is the most used circuit because almost every electronic appliances that operates as a direct current, that means a DC. But the availability of the DC sources are very limited. Such as we know electrical outlets in our home also that provide AC. Alternating current. So the rectifier is a perfect component for this jobs in industries and hopes to convert the AC into DC. So even our cell phone chargers also use rectifiers to convert AC from our home outlets to the DC. So we can have the different types of rectifiers that are used for some specific application. So let us discuss one by one. Yeah, as I told already, the electronic component that converts the alternating current into the direct current. That is ensuring the unidirectional flow of electric charge. So here we have the types of rectifiers. One is single phase rectifier, another one is three phase rectifier. So single phase rectifier is nothing but it uses a single phase AC supply which has a one alternating voltage cycle that is commonly used in a small electronic devices. So there are two main types. One is a half wave rectifier, another one is a full wave rectifier. So half wave means it allows only half of the AC cycle. Full wave means it converts both halves of the AC cycle. And next one is the three phase rectifier. So the three phase rectifier, it uses a three phases AC supply which has a three alternating voltage cycles, each 120 degrees apart. So it provides a more constant and more smoother DC output compared to the single phase rectifiers. So it's often used in some industrial applications and where the power and efficiency are needed. So these are also have half wave and full wave versions. So what is the main difference between them? So it uses as I said earlier, it uses a power supply, two wires power supply, and it can deliver only a small amount of power. It is not very efficient that compared to the three phase rectifier. So the DC output has some lot of fluctuations, that means ripples. So it is not very smooth. On the other hand, three phase input is 3 wire or 4 wire supply. And it can deliver a lot more power, and that making suitable for the bigger task. And efficiency wise, it is a very efficient, that means it wastes less energy. So next one is the DC output ripple factor. So ripple factor is less, that means DC output it is much smoother with fewer ripples or fluctuations comparatively a single phase rectifier. And TUF is nothing but transformer utilization factor. So TUF is nothing but transformer utilization factor. It uses the transformer's capacity much better, making it more efficient. So usually you don't need extra filters because the DC output is already quite smooth. This three-phase rectifiers, and peak inverse voltage also high in this. So furthermore, rectifiers, we have two types, uncontrolled and controlled. So what is uncontrolled and controlled? So uncontrolled rectifier in the sense there is no control over that. So we can use diodes. So the diodes means we have already know which allow the current to flow only in one direction. Once the AC is supplied, the diodes automatically rectified AC into DC without any external control. So we can't adjust, we can't control the output voltage or output current here. That is what the uncontrolled rectifier. Next is the controlled rectifier. What is this controlled rectifier? So uses some thyristors, semiconductor devices that can be controlled by the external signal. So this allows you to control when the rectifier starts conducting. So effectively that controlling the amount of AC that is converted to the DC. So here the output voltage and output current that can be adjusted by varying the firing angle. So what does it mean by firing angle? The point in the AC cycle when the thyristor starts conducting. That is what the firing angle. So this provides a greater flexibility in controlling the power that is delivered to the load. So this is what the main difference between the uncontrolled rectifier and controlled rectifier. So today we are going to discuss about the uncontrolled half wave and full wave rectifier. Let us see. So single phase uncontrolled rectifier with R load, that is a half wave and full wave. We are going to do the demo also. And this is what the block diagram of the uncontrolled half wave rectifier. So this is the half wave rectifier. You can see the AC source and diode and resistor load. And this is your input and this is our output. So let us see, we will get the same output in our simulation. I'm going to open the new Simulink page. So the half wave rectifier means it rectifies, it converts only the half cycle of the alternating current into the direct current, which is known as the half wave rectifier. And for that, we need AC voltage source and diode, one diode and resistor load. Let us see. We will get the same output from that slide diagram. I'm going to select the block diagram. That is the AC voltage source. Just type the block name. Just double click on the workspace area. If you know already the block name, you can directly type that name. Yeah, so this is voltage source, AC voltage source. Yeah, so this is AC voltage source. And next I need diode from the library. And next, what is that resistor I need? So I'm going to type the series RLC branch. Just select the series RLC branch. Just double click on this. You can see the branch type. I'm going to select the branch type as a resistor and give apply and give OK. So I'm going to now rotate this block. So what is the procedure? Press the Control R. So first you have to select the block and press the Control R. So this is the control or rotating the element. Now I'm going to connect all this element. So the plus to plus and the cathode to plus and minus to minus. Yeah, so this is my simple circuit. Okay. Now I'm going to take the scope. So just take the scope. This is my scope. And you can directly connect by using the voltage measurement. So just take the voltage measurement, one for the output. And just check the another one. This one for the input. So this is the input and this one is the output. So just click this show block name all here. So this one is okay. Just double click on the scope. Go to this view and select the configuration properties. Number of input ports we are going to take 2 and select the layout as itself. And apply. Okay, the first one is input and the second one is output. So now we need a most important block, that is a power guide block. Without this we can't solve, we can't run the simulation. And yeah, everything is clear. I'm going to run the simulation now. Let us see the output. So before we see the output, I will explain what is happening here. Let us see. First see the output. Okay, so just select this full view autofill and select the, here we will get the sine waveform. Now I am going to change this continuous to this discrete. Let us see the clear sine waveform. We will get the pure sine waveform. Just press the Control T, that is a shortcut for your run. Yeah, okay. Let us see the scope here. Yeah. So here we will get the output, same output. Yeah. So this is our sine wave. This is my input and this is the output. So what we will get here? So during the positive half cycle, I will show you. Okay. Yeah. So during the positive half cycle, okay. So this is my positive half cycle. So the diode, the terminal, yeah, let us see. Sorry. Okay. Okay. So now I'm going to show you the output. So during the positive half cycle, the terminal anode, so the diode terminal anode, it will become positive, and the cathode, it will become negative. So that is known as the forward bias, and it will allow the positive cycle to flow through. So this is what during the positive half cycle. So that is why we are getting the positive half cycle, we will get the output. So during the negative half cycle, the anode will become negative. So the anode will become negative and the cathode will become positive. So which is known as a reverse bias. So the diode will block the negative half cycle. So when AC source is connected to the half wave rectifier, only the half cycle will flow through. So the output of the resistor rectifier, it taken as across the resistor load. So what is output here? This is what the pulsating positive half cycle. So it shows the pulsating positive half cycle of the input. Here the output of the half wave rectifier has too many ripples and it is not very practical to use the output as a DC source. So we are going to smooth this pulsating output. So by using this capacitor, thus I am going to add the same thing. Just press the control and drag from that block, that is the resistor block. I am going to choose the capacitor here. Just apply. Yeah. Now I am going to connect across this resistor. Now we have to filter out the pulsating output by using this capacitor. So if you do this, you have to increase the capacitance and increase the load resistance also. A larger capacitance value that will store more charge and that helps smooth and out the ripples more effectively. So you can experiment by increasing the values of the capacitor in your model to see how it affects the output waveform. And at the same side, you have to increase the load resistance that can reduce the current fluctuations also, which might slightly reduce the ripple in the output. So I am going to increase my load resistance to the 100 ohm. And the capacitor, it should be 100 e power minus 6, sorry. Okay. Just press the Control T. Now let's see the output. Yeah. So it's absolutely see, you can see. So this is the ripple is reduced. Okay. The ripple is reduced. So we will get some smooth output by using the LCL filter or LC filter also. So this is what the concept of half wave uncontrolled rectifier, because here we are using the diode. So now I am going to open a new Simulink for the full wave rectifier. Let us see the full wave rectifier diagram. Yeah, so the same output, we got that half wave rectifier. And this is the uncontrolled full wave rectifier. So the full wave uncontrolled rectifier, it converts both positive and negative half cycle of the alternating current into the DC current. So it provides a double output voltage that compared to the half wave rectifier. So here also there are two types. One is a center tapped, another one is a bridge rectifier. So bridge rectifier, it consists of the 4 diodes. I will show you that one. Okay, I will show you that one, just a minute. Yeah. So this is what the full uncontrolled rectifier. And now I'm going to do the same thing here. This take the AC voltage source. This one is AC voltage source. Take the diode. And take the another one. So here we are using the 4 diodes. Just connect all the diodes. So we have to connect the input and also cathode to cathode. And connect the resistor load. Okay. Just check the series or LC branch. And now I'm going to select the resistor. Just connect this resistor across the circuit. Take the voltage measurement block and just connect the voltage measurement block. Take the scope. So connect the scope and take the another voltage measurement for the input. So you have to connect across this one. Okay. So this is the input and this is the output. And I'm going to add the power guy. Just take the power guy to continuous to discrete and apply and give OK. Now I'm going to run the simulation. So let us explain what is happening during the positive half cycle and what is happening during the negative half cycle. Go to this view page and select the layout. To see the output. Yeah. So here you can see we will get continuously positive half cycle. So what is exactly happening here? So during the positive half cycle. Here we have 4 diodes. So the diode D1 and diode D2 becomes a forward bias, while D3 and D4 becomes a reverse bias. I will show you in this page. Yeah, so this is the full wave uncontrolled rectifier. You can see, so the diode D1 and diode D2, it becomes a forward biased, while D3 and D4, it becomes a reverse biased. So the diode D1 and D2, it forms a closed loop and that provides the positive output voltage across the load. So this is the voltage. The blue color indicates the voltage and red color indicates the current. So next, during the negative half cycle, D3 and D4 becomes a forward bias, while D1 and D2 becomes a reverse bias. So but the polarity across the resistor load resistor, it remains same and provides a positive output across the load also. So this is the main difference between the half wave and full wave. So the output of the full wave rectifier, it has a low ripples compared to the half wave rectifier. But still, it's not smooth and steady in the sense. In order to make the output voltage smooth and steady, you can use a capacitor placed at the output. I will show you. Okay. Yeah. So you can add the capacitor across the resistor. So the same way you can increase, you can increase the capacitance and do the trial and error method. You can get the better smooth DC waveform. And now I am going to run the simulation. Yeah, let us see the output. So what is the output here? Full wave rectifier. So this is my full wave rectifier output. Yeah, you can see it's smooth. It's nearly going to smooth. So you can change the capacitor's value and also you can change the resistor value. In the sense you will get the smooth output, or also you can use the LC filters or LCF filters. So this is what the what is rectifiers and difference between the controlled rectifier and uncontrolled rectifier. And today we will discuss about the we have seen uncontrolled half wave rectifier and uncontrolled full wave rectifier. I hope you can understand this concept well. And before we are going to leave the session, I will give you the internship details. You can convert the masterclass into 1 month internship. So what are the benefits you will get? In the sense you will get 30 days of recorded sessions. But in live class, you will get 21 days free live sessions. For benefits of the internship, you will get 30 days. So all 30 days presentations, PPTs and exclusive projects, simulation files. And additionally, you will get VIP community group and for the doubt clarification and internship updates. And you will get the internship confirmation letter from the IET. And also you have to access the course for the 90 days and you will get the assignments and tasks, and you will get weekly live sessions, and you will get the resume building and mock test and internship participation certificate also. So this is our bundle, join our 3-in-1 bundle, that is renewable energy, Matlab, Simulink and power electronics. The same benefits you will get here. You will get certification, 1-year validity of LMS portal and assignment and weekly live sessions. So additionally, you will get 2 additional masterclass. One is renewable energy, another one is Matlab Simulink. So this is all about today's session. So thanks to everyone who joined today's live session. Thank you for watching. Keep supporting us. So thank you so much.